Hi, I'm Nick from ScanFlow Solutions, and I've used this scanner in the most unexpected and surprisingly effective ways. In this video, I'll show you how one compact tool can solve real-world challenges. From scanning disconnected indoor and outdoor areas for planning underground drainage, to smart scanning strategies that unlock complex building layouts, to capturing entire roads and intersections for transport route validation, and even generating clean terrain models for Revit in just minutes. Honestly, the only thing it doesn't capture is how much time it saves me. If you are looking for a reality capture solution that works like an army Swiss knife, versatile, fast, and unexpectedly powerful, you're in the right place. In this use case, we had a very specific challenge: planning a drainage pipe that runs from a courtyard out to the exterior of a property. Sounds simple, right? But there's one big catch. There's a basement in the way. The drainage route has to go through the basement. A basement that's used as a cold storage room, already full of existing pipelines and ceiling hung lights that could easily become obstacles. Wouldn't it be perfect if we had one clean vertical section view that connects the courtyard, the basement, and the exterior, all in a single scan? That's exactly where the scanner comes in. Thanks to SLAM and RTK, we're able to capture all the relevant environments and link them together in under 15 minutes. Honestly, explaining the problem takes longer than solving it with this scanner. Let me show you the strategy we used to capture this space efficiently. Step 1. A good scan starts with a good plan. You need to understand how the scanner works, and you need a smart scanning route. For this project, we decided to use the RTK antenna to assist the SLAM algorithm outdoors. So we started in an open area with strong satellite signal, right at the only entrance to the basement. That way, we ensure the first loop closure happens right before we go underground. Next, we walked the entire outdoor area slowly and paid special attention to one key feature: a light well leading into the basement. Why? You'll see in a second. After returning to the start point and closing the first loop, we entered the basement. Naturally, we lost the RTK signal. From here on, SLAM had to do all the heavy lifting. We walked directly to the area of interest, scanned carefully, and headed back towards the light well. Here's the clever part. We passed the scanner up through the light well to a second person waiting outside. Since we had previously scanned that exact area, this move instantly closed another loop and corrected any SLAM drift happened in the underground. We then walked back to the original start point to close the final loop, and just like that, the scan was complete. And yes, it worked surprisingly well. The only trick is knowing how to move the scanner smoothly through tight spaces. And take a look. The very moment we pass the scanner through the light well, you can see the trajectory snap into place in real time. Pretty satisfying. And by the way, the real-time loop closure indicators in the FJD Scan app incredibly helpful. You won't find that in other systems. Now, let's extract a clean vertical section from the point cloud ready to be used directly as a planning base. Super easy. And just to show how well the georeferencing worked, here's a point cloud from the airborne laser scanning, captured years ago and also georeferenced. The alignment is just spot on. Convincing, right? Alright, one loop closure, one basement, one light well later, problem solved. But now we're taking on a more classic challenge: scanning an entire building. Sounds straightforward, right? Well, let's just say, with the right workflow, it can be. Let me walk you through how we captured an entire building structure, floor by floor, inside and out, without missing a beat. In this next use case, we're scanning an entire building. one of the most challenging environments due to narrow corridors, changing layouts, and multiple floors. Planning the route and understanding your scanner is crucial here. To ensure data quality, we keep scan missions short and create reliable loop closures. Since loops are hard to close indoors, we shift them outside. First, we scan the exterior with RTK and return to the same point. Using the continuous scanning for splicing feature, we start a new scan and move inside, up to the next floor. Through opened windows, we hold the scanner outside to connect back to the exterior scan, creating a vertical loop closure. We repeat this for all floors, always starting outside and linking back to the very first scan. We also use a telescopic pole to reach over walls and capture otherwise hidden areas, like roof structures in the attic. In Trion Model, we import all missions into one project. With one click and splicing registration, we register every point cloud to the very first one. To avoid duplicates, for example in the stairwell or outside, we use clip by path to clean overlapping areas. Then we merge all point clouds into one and export for CAD. That's how we capture complex buildings, fast, smart, and accurate. Reality capture can be that simple. Now let's look at a very exciting use case: scanning a heavy transport load right during loading onto the truck on the industrial site. The challenge: the oversized cargo had an attachment that might collide with an overhead pipe bridge on the facility grounds. We scanned the loaded cargo first, then scanned the pipe bridge to check clearance. The result? A gap of about 4.7 centimeters, just enough to safely pass through, without any time loss on decision making. With this quick scan, we turned uncertainty into clear, measurable data, right on site in real time. And if you want to see the full workflow on how to create terrain models for Revit, write in the comments workflow and I'll send you the full video.